today. I hope you've had a fantastic day. I've had a fantastic day. We have a little bit of a special thing that happens in the education track, well, has happened for the last 2 years. In the afternoon session, we hand over to high school students and find out what they've been doing with Python or what they've learned about programming. And so we have some fantastic 8 groups, 9 students, to show you today their work and talk about their ideas. We're going to move fairly quickly through that. That's 10 minutes each, and then a little bit of changeover time. So there's not going to be probably time for questions of individual students at the end of their talks. But they're all staying here. They're in a group. And so they're welcoming questions at the end. So if you'd like to go and ask for more detail, please do. They're very friendly, I promise. Okay, so the other thing is we don't have a full bio for all of them to try and keep it short as well. Okay. So without further ado, I'd like to introduce Eliza Lee, who's going to be talking about Sentiment Puppy, her sentiment analysis. Eliza, can you come up? And just by way of introduction, yep. Eliza, what's your favourite dessert?
Honestly, anything with chocolate is really good.
Okay, and how long have you been coding?
I've been coding for around a year. I'm going to be honest with you. Today really isn't my day. I'm just not really feeling myself, you know. It's one of those days where you wake up and you think to yourself, today is a day where something will happen. And your eyes close, and then all of a sudden you're fighting dragons, and something really is happening. And that's when I wake up, again, to the sound of my alarm screaming at me right before my mum does. Oh wow, this day sure started well, didn't it? So here's a question to you all. What sentiment was I giving off? I was frustrated, a little upset, and undoubtedly annoyed. Overall, it was pretty negative, wasn't it? So negative that you're probably thinking, oh, come on, you're young and you're small and life is great. What is there to worry about? But how did you know that the overall sentiment was negative? How do we know what's positive and what is negative? These were the things that I thought about when I first sat down and began planning my project. As humans, happiness, sadness, anger, these emotions are so ingrained within us that when communicating with others, we pick up on it without a second thought. But how would a machine know whether a series of words or a piece of text contains positive or negative sentiment? I found this idea undeniably intriguing when I was first introduced to sentiment analysis. Shout out to Nikki, who first introduced us to this. And I remember thinking, how cool is it that a machine can be trained to mimic such an innately human trait of identifying emotions? But what exactly is sentiment analysis? Sentiment analysis uses computational thinking to classify a series of words into the opinions and feelings in a text, and this tone reveals the author's attitude towards its particular subject. For those who like big words, I've also put up Google's definition too. So how does this process work? I've broken it down into a couple of steps which I followed when coding my program. Just like how we humans are trained to associate certain emotions with particular words, the computer also needs a form of training. We need a library of words that have already been assigned a sentiment value. Our trained corpus allows us to sort out our data by recognizing the words that are present and matching the values. Next up, we gather our data. For my project, although I was focusing on Twitter and therefore my data would be tweets, a basic sentiment analyzer was built first before integrating the Twitter sections of the code. So I just gave my initial program a block of text to test on. The text is then split into its basic components, and then the words are tokenized into different categories of text, such as verbs, nouns, adjectives, and adverbs. When analyzing the sentiment, adjectives and adverbs are crucial in determining how positive or negative the input is, because when we speak or text, that is where we usually place emphasis to reveal our perspectives and emotions. For example, consider the following statement. I am a dog. We can add an adjective to it so it becomes, I'm a happy dog. Or alternatively, I'm a sad dog. Our sentiment analyzer then predicts the polarization of the text that we've given it by assigning values of positive, negative, and neutral. And between positive and negative, whichever value is greatest determines how the text has been categorized. So I've taken that utterly devastating story I started this presentation with and chucked it into a basic sentiment analyzer. Here is what it came up with. You can see that I was generally pretty successful in realizing that I'm not being super happy. You can see that in those 3 middle sentences, the value for negative is much larger than the value for positive. And the compound, which is the result of both the positive and negative values, is negative. And look at this, the 4th sentence is doing super well. And that's when I wake up again to the sound of my alarm screaming at me right before my mom does. Kidding, I love my mom. And don't worry, she doesn't actually scream at me that often. If you look at the first sentence, however, you can see that it has a lot of neutral words, and it has a tiny bit of positive, but it doesn't pick up on me saying that it wasn't really my day-to-day. And so the analysis contains no negative values. And I go into this a little bit more depth later, but I think I'll just mention here that even though my analyzer is just a basic one, sentiment analysis in general is super tricky to make accurate. We can see this quite evidently when we look at the last sentence, of which I'm sure you guys picked up on my sarcasm when I first said it, but the analyzer blatantly didn't. It's looking at my sentence going, oh my gosh, look, she's finally feeling a little bit more positive. Like I said before, sentiment analysis has a lot of challenges because let's be real, getting a machine to understand human speech is really difficult when our language is constantly fluctuating. Here are a few of the main things that normally trip up our analyzer. Contrastive conjunction, which is when a piece of text contains both positive and negative words, happens all the time, but it's quite difficult to deal with. Everyday sentences feature these pesky things such as, I love ice cream, but I hate it when it melts all over your shoes. Named entity recognition is also another challenge for our sentiment analysis. Although we do have a method of overcoming it, I haven't been able to implement it. Our problem here refers to the context of our sentences, because many words may be spelled the same, but have different meanings depending on the context of it. Say, for example, I mentioned that I bawled my eyes out when watching 5 Feet Apart. Shh, don't tell anyone else that. But would the analyzer know that I'm talking about the movie? Or would it think that I'm talking about something that's 152 centimeters away? And if I said Milky Way, am I referring to chocolates or the galaxy that we're in? Another major problem that I briefly mentioned before is our use of things such as sarcasm, slang, speech, acronyms, puns, all of these things, and many more make our language super hard to decipher, especially when we're online. But I mean, on the good side, that means that aliens won't be able to mimic our language and hack into our systems, right? Kidding, they'll probably still find a way. Wait, what if I'm presenting to a crowd of aliens? All right, moving on. Sentiment Puppy is a bot that I created that utilizes sentiment analysis to analyze tweets and classify these tweets into the categories of positive, negative, or neutral, and subsequently replies to the original user depending on the analyzed sentiment. At least that's a goal. Well, okay, so far I've gotten pretty close to what I'm trying to achieve. My current bot integrates the sentiment analyzer I previously discussed to analyze tweets. It checks its timeline for tweets from users that it follows, and when it comes across a tweet that is negative, it tries its best to cheer them up with an automated message and a picture of a puppy. What can I say? Life is always a little bit more happier when there's a dog nearby. I also ensured that a bot would reply to its own tweets. Wouldn't reply to its own tweets. By checking the user ID, and if it corresponded to my own, the bot would ignore the tweet. The image generated is from a dog API, which increases the use of a large variety of pictures instead of repeating and randomizing the same ones over and over again. One of the biggest challenges is that my bot, although it does successfully analyze a tweet and reply to the original tweet, is unfortunately starting to look a bit like a spam bot, because when I run this program each time, not only does it reply to its new tweets, it also replies to previous tweets that have already received their share of a puppy. In the image to the left, you can see that the bot keeps replying to a tweet, even if it has already replied previously. Another challenge was figuring out how to reply to the original tweet, instead of just posting it in my timeline. The other image, so down at the bottom, it was a failed attempt, but I got there in the end. Here you can see the image that I managed to finally reply directly to the original user, but we're still having the same issue of spam replying. I was hoping to overcome this challenge by first checking the replies to the tweets, and if there were already replies from my bot, then the bot would ignore the tweet. However, I haven't been able to successfully implement it yet. Some of my future goals also include training my own Twitter corpus based on emojis by helping the bot recognize words that are frequently associated or used with a specific emoji, then testing it to see how accurate it is in comparison to other corpuses. I'm also considering implementing a feature to the bot to provide users additional support by allowing the bot to contact a trusted adult. This is for cases where there is a noticeable pattern of negative sentiments for a single user. So thank you for listening to my presentation, and feel free to follow my bot on Twitter if you're a little daring and don't mind being occasionally spammed with tweets. Thank you.
Thank you, Eliza. Okay, next up we have apparently websites are slow. Joshua Whitmore and Rohan van Klinken talking about developing and implementing a Harry Potter house point system. Joshua, what's your favourite dessert?
Anything with custard, really.
Okay, and how long have you been coding?
About 3 years.
Thank you. Rohan, what's your favourite dessert?
Apple crumble.
And how long have you been coding?
About 6 years.
Okay. Who's taking the mic?
Might you first.
Round of applause, please. Thank you. Well done.
Hi, I'm Rohan.
And I'm Josh. We are both from Brisbane and attend Kelvin Grove State College.
In 2018, we won the Queensland Premier's Coding Competition, and because of this, the school tasked us with creating and implementing a digital solution for storing, adding, and displaying points through a website.
During the last week of term, we took the challenge, and within 3.5 days, we'd implemented the majority of the required features. After this, most of the work was refining the usability and making requested changes, which were decided at a series of meetings with teachers.
First, we'll show you it in action with a live demo, and then we'll get straight into how we created it and got it up and running.
Let's start at the sign-in screen. We'll sign in as a teacher for now, as it loads. Here is the homepage, where you can easily see all of the house points at a glance. We used a tile design to include the school's new Indigenous house artworks as the backgrounds for each house. The school's House Totems initiative was a finalist in the 2019 Queensland Reconciliation Awards. The artworks we were required to use were part of this initiative. To make sure that the website was using the artworks in a culturally appropriate way, the design had to be accepted by a board of Indigenous elders.
To view the history of a specific house, you can just click on the house's tile to find out. At the moment, Herbert has the most points. We can see that most of their points come from sporting. The links at the top of the page can be used to filter by sub-school. And we can see that at the moment, none of Herbert's points are earned by the junior school.
There's also a display mode, which was designed to be shown on screens around the school and for students to view the current point standings without having to sign in.
I don't know what just happened there.
You can get out. Yeah. There we go.
This is the award points page, which is where teachers can add points. Because the school trusts us not to add points, we probably shouldn't add any today. The statistics page contains a donut chart showing the distribution of points between the different houses and a bar graph showing the distribution of points across the different reasons. Please take a moment to appreciate that the donut chart is pure CSS. It took quite a while. You know how CSS is if you've used it before.
After that, we have an overall history page, which shows the specifics of all points added that year. We'll sign out now, and then back in as an admin. The admin page, as you probably guessed, houses all the admin features. This includes features such as resetting passwords, removing and adding users, resetting the database, and downloading the current and previous databases for backups. Now it's time for how we made it. Let's begin with the Python code, which, as you've probably already guessed, we used for the backend. We decided to use Flask and not Django because it was the one we had prior experience with. To make things easier to read, we split the code across two files, one with all the main Flask functions and one with the helper functions.
Don't even try looking for hard-coded passwords. We're not that lazy. All of the users and passwords are stored on a free remote MySQL server. Before we moved to the remote MySQL service, we were just using the SQLite that comes with Python and a local database. We had to move away from SQLite though, because as far as I could see, it didn't support remote MySQL databases. So I converted all of the code to using PyMySQL, which took some intense finding and replacing. And with some more manual fixing and bodging, we got the code to work properly again. We'll explain why we moved to a remote database a little later on after the rest of the code.
Next, let's talk about the front end. For that, we use Jade and Sass preprocessors for HTML and CSS because we like the syntax of them much more than their traditional counterparts. We spent a portion of the first weekend at the Christmas holidays writing media queries to get the website looking nicely on mobile. To get data from the Python backend into HTML, we used a feature included in the Flask's render template function called Ginger. For those that haven't heard of it before, Ginger is a web templating engine that extends on HTML and can handle basic data operations like rounding numbers and capitalizing titles.
Talking about front ends, Internet Explorer. We still haven't quite got that part working yet. If you have any tips about styling grids in Internet Explorer, please feel free to tell us afterwards. As well as Jade and Sass, we used a bit of JavaScript for the fancy loading effect, updating the points every 30 seconds in display mode and some client-side form validation.
Another requirement of the project was that we had to make some simple documentation for teachers, admins, future students tasked with the horrendous job of figuring out someone else's code and fixing it. And last but totally not least, a highly detailed README. And that's the code done.
To host the website, we decided to use Heroku because we have used it before. It was also appealing because of how easy it is to set up with Git. However, it did take a bit of trial and error to get the configuration files correct. This clogged up our Git commit slightly.
After we had Heroku set up, we thought that we had pretty much finished, except for a few more tweaks that had been requested. But no, we started getting emails from teachers testing the website that went along the lines of this.
The points seemed to be disappearing every day. I thought that maybe I'd taken too many shortcuts in the database handling and wasn't closing the connection every time. So I added the line to close the database whenever the code had finished with it, but after a day, the points had disappeared again. I tried a few other things, and it still kept happening. I started to get suspicious that it was something to do with Heroku, and sure enough, it was.
Apparently, Heroku resets all files every 24 hours, so the database was resetting to an empty version that we'd been pushing along with the code.
And that's the story of why we had to move to an external MySQL database. Using the external database is actually much more convenient than using the local one, except for occasionally when testing.
That's all we have for you today.
Thank you for coming to listen to us, and enjoy the rest of this year's PyCon.
Thank you. Okay, next we have Stephan Kashkarov.
I'll grab that.
Yep, sure. No problem, you got it. Okay, it's there. Yeah. Triangle sticks, making GUIs or GUIs in MicroPython.
I've renamed it a bit.
And he's renamed it a bit, so he'll be telling us more about that in a second. Also, what's your favourite dessert?
My favourite is sugar.
Straight sugar, all right? Said all males ever. And how long have you been coding?
About 2.5 years.
Okay, there you go.
Thank you. So, hi, so my name is Stephan Kashkarov, and I'm a student at Klinken College. So I consider myself to be a bit of a tech enthusiast, but as a college student, I don't really have the money to be a tech enthusiast. So the only real way I can get any kind of tech is by making it myself. So when my 2 lines of IT decided to have their semester-long major project, I decided that it would be a great idea to take this opportunity to make my own smartwatch. So this is the original design that I came up with because I just jumped right into it straight away, which I completely regret. But so basically what I wanted to do was to make it completely consumer electronic, like complete PCB, all of the components all together, and I wanted to do it straight away. So I chose this processor. This is an ESP8266, which is like an Arduino, but I didn't choose an Arduino because this is a lot smaller. It comes with default Wi-Fi, and it can run with MicroPython. And another reason for me making my own circuit is because most boards that use an ESP8266 run with a 4 megabytes of flash memory, and since I was taking up 2 lines of IT, I didn't really want to, I wanted to go all out in the software as well as the hardware. So I decided to upgrade the storage that I could have on the chip. So this was my first prototype. I was, yeah, it wasn't that good. So basically, you can see the screen up the top here. And then I had 16 buttons. So each of these buttons count as 1/16 of the screen. And the idea behind this is you can pretty much press it and it should work. The thing is, this one never worked. And so the problem with it, I plugged it in and it wasn't really working. I wasn't getting any values. So then I tried prodding it with a voltmeter, and then some magic smoke happened. And yeah, so I quickly moved on to the second design. So this one's a lot more simple. Basically, I use a potentiometer. This is actually the design I have here today, and you can see the slideshow in the back. But so the potentiometer, basically, what it does is it moves the, you can scroll with the potentiometer to move the cursor across the screen and press the button to switch for X and Y. This design was a lot like, it looks like a smartwatch compared to the last one. It's a lot smaller, less bulky, a bit easier to use, and it looks a bit less dangerous. So where is the touchscreen? Because, you know, smartwatches, they should have touchscreens, right? Like, you're not going to have buttons on a smartwatch. That's so 2018. So I did actually think of buying a touchscreen, and they sell pretty cheaply, despite the shipping for some reason being twice the price of the actual product. And also 20 days for the cheapest option. But so I did get this, and I got it shipped to my house because it wasn't that bad. Like, it's not too much. It's reasonable. It's student budget, works out. So I got it shipped to my house, and then I put it on my desk, and I worked on a few other assignments for a bit. But the problem is, when I came back to work on this project again, it just wasn't on my desk anymore. I wonder where it went. So yeah, it didn't go too well there. But maybe the software went a bit better. So. So when I started with the software, I wanted to make something that was really expandable because I wanted to do whatever I want. It's my own smartwatch. I can do whatever I want, hopefully. I wanted it to be quick because I wanted it to be quick. And the chip itself is a bit weak, so I didn't want it to run really slowly. I wanted it to be compact because I didn't have that much memory, as I said before. And I wanted it to follow the formulas of stuff that you see in real life. I know React is a very popular framework, so I wanted to try and make something that's similar to that because maybe people will make apps for me, hopefully. So I decided to create the UI in a tree-like structure. So basically, all of the UI elements are treated as components, and they all have subcomponents. And when I render the device, it takes all of the subcomponents, and so basically in this status bar, for example, I would take the battery, I would render it as a component, then I'd put it on top of the status bar, then I'd render the status bar, then I'd put it on top of the device, and then I'd put that all to the screen all together at once. So here's some sample code of how that would work. As you can see, in my device, I have a row object. Inside that row object, I have a box, a red box, and I have another box, which is below the row, which contains another box inside it, which is red. So I'd have a red box, a black box, and then on the bottom, I'd have a blue box with a red box inside. But then I realized that I still need to work on the actual interface with all of the components, like the touch screen and the screen and the Wi-Fi, accelerometer, LEDs, anything I wanted to add, because I wanted to make this very modular system. So I went and did that. So I made this, like, for example, on the right, you can see the component class. And basically, that's all of the code that I wrote. So if people made apps for me, they would only have to write the code on the left. So you'd create your own class, subclass it as a component, and you just need to write your render function, fill out a few params and a few like hooks for interaction, and you should be good to go with your own like apps. But then I realized that I still needed to handle interaction, and interaction was a lot more complex than I expected because I need to take into account where the interaction happened, which element on top of my massive like very thick like net of components, which one I was actually like talking about. So I'd take the interaction, then I have to go find the module, I'd enter the component tree, go through all of the components, and then if I find one which has the correct interact hook, then I'd execute it. Otherwise, I'd just leave the program. So you can see I've did that. You can see some actual MicroPython on the right side because that's yeah, that's what it kind of looks like. Not that much different from regular Python, but so yeah, so I did that, and then I realized that I was making an OS, and OS is very complex. So yeah, yeah, it didn't go too well. So what I learned overall in this project is you should always plan before you start. So one problem I had is I wanted to go straight into it, make it all straight away. I still am planning to continue on this project as like, you know, it's not the end of the semester yet, it's only the beginning. So right now what I'm going to do is I'm going to go and I'm going to sort out everything that I have, make sure that I know every single subsystem that I'll need in advance before I go into the project, so I won't need to worry about it later. I'd also limit the scope, because when you do major projects of any kind, if you do too much at the same time, you can get into a thing called feature creep, where you're like, oh, that's cool, let's add this. And then you add so many things that it just goes way out of proportion, and you just spend too much time working on it, you lose motivation, and then you never finish the project. So it's important to always have a limited scope. And a way to combat this is to use a thing called MVP. MVP stands for a minimum viable product. Lots of companies use this. I wouldn't be surprised if any of you have heard of it before. Basically what you do is you define the minimal thing that you can use. So basically that would be like, on my smartwatch I needed a touchscreen, and I need a screen, and it needs to show me the time. So what I would do is I'd get everything that I need to do those things, and then I just work directly towards that, not even thinking about anything else that happens on it. So once I get that done, then I can think about other things. And then I can work towards things, and then it organizes how I work on everything and make sure I never like start bogging myself down with too much work. So thank you. I think I spoke very quickly. But if you have any questions, I have my smartwatch here. I can show you guys. It doesn't really work, but yeah, so I'll be ready at the end. Thank you.
Thank you, Stephan. Okay, next up we have Anna Brew. And Anna Brew is going to be talking about using Python to teach you maths. I have you here somewhere there. Thank you, Anna. Okay, Anna, what's your favorite dessert?
I've thought about it very hard, apple pie.
Okay, and how long have you been coding?
Since year 8, so like, I'm in year 12 now, 4 years.
There you go.
Hi, I'm Anna. I just said I'm in year 12. My trials are actually 3 days away, so even though I'm talking about using, oh no, I didn't start the slideshow. Sorry, 1 second. So I'm talking about using Python to do maths, but I did not calculate that August the 5th minus August the 2nd leaves me 3 days to learn the entire English syllabus. So before I talk about maths, I want to talk a little bit about how I got into coding. Because like obviously we've seen that the Python can be used to do some really like incredible things and incredible projects, but this is more about like using Python to help me learn other things like maths specifically. So, hello PyCon. Anyway, so I got into coding in year 8, as I mentioned. It was year 8 design technology, and I went into the coding unit dreading it completely, but knowing I had to do well, because the unit before was textiles, and we were making hoodies, and I kind of sewed across here, which is where the torso goes. So, parent-teacher was coming up, I had to redeem myself. Anyway, I was absolutely dreading it. We did the NCSS challenge, and first week, second week, I was like, this is awful, this isn't fair, who needs to code anyway? But obviously, here I am. I actually switched from photography to IST, a subject I'd previously called my friend a loser for doing. So that was like delayed self-burn on me. Forgot that slide was there. So I'm talking about how I used Python to help me with polynomials. I've used Python to code a lot of random things in math, and I never really get around to finishing them because it's coding for me, not for other people. Anyway, so I'm going to do a quick crash course on polynomials. It's going to be a bit bumpy because, like I said, I did this because I struggled with the NASA-approved safely landed course on polynomials. So we'll see. So a polynomial is just a thing with many terms. So I'm so sorry. Yeah. This is a term. It has 2 parts. So the A is called the coefficient and the N is the exponent or the power. Sorry, I keep moving the microphone around. Okay, so I was really struggling with dividing the long division of polynomials. I never actually got around to coding that, but the reason I couldn't do it was because I just had no idea what a polynomial was in the beginning. So my first attempt was very literal. I was like, a polynomial is a thing with a bunch of terms. Why don't I just put a bunch of terms in a list and call it a polynomial? And that did not work great. So it kind of worked for some things, but every time I wanted to get to the coefficient of a term or get to the degree of a term, I had to do regex, which was a skill I learned at NCSS and I'm abusing to this day. Oh, right. So I was looking at this and I was like, this is a project I'm doing for fun. I know I could use classes, but I'm not going to learn a whole new part of Python for a project that isn't even going to be marked. That would be ridiculous. So like a responsible student, I opened my English homework and then I closed it and I was like, Python, classes, how fascinating. Wow, coding, we love. So this was literally my first attempt at classes, so let's be nice. So, right, this is a class that defines a term. So basically all it does is it takes the string term that I showed you here and it does all of that regex for me so I don't just have to copy and paste it a billion times and hate myself. Yeah. I definitely had something to say about this slide. We're going to move on. Oh, you can't see it up there, but I got very creative with the PowerPoint highlighting. Those are actually glitter pens, so... Right, so this class is a polynomial, and basically all it does is it's a list of terms. But there's one part of a polynomial that you use a lot, which is the degree of the polynomial. It's just the term that has the highest power. So in the example below, it's a 3rd degree polynomial, or a polynomial of the 3rd degree, I don't know. So the bit at the bottom is finding the degree, and looking at it now, I probably should have made that a method, but too late. Okay, so these I did, oh, that's a video that's already playing. Sorry, my slides are in the wrong order. Okay, so this is a demo of my code working. The bit at the top was last night when I learned that I can't have decimals in my coefficients. So that's an easier example below. It's going to find the roots of the polynomial, which I should explain are where the polynomial crosses the x-axis. That was a key part of my explanation I left out. I got overconfident, I didn't look at the notes. I'm very sorry. Look. Those are the roots. Unless you want to do some quick maths, I can't prove that it's the roots, but you're just going to have to take my word for it. Anyway, so that worked. This was way harder than I thought it would be. Backwards. Oh, so this is my possible roots of a polynomial function. Sorry, mind blank. So it takes... So basically, there's a feature of polynomials that all of the possible roots are the last... the factors of the coefficient of the last term over the factors of the coefficient of the first term. So that's how I got these. So I had to write a bunch of different functions to actually, do this. So Right. Sorry. So basically all this does is it creates a list of possible factors, which is a function I'm sure I included somewhere. Have I been on? Oh. Right, so it gets all of the possible roots of the polynomial, and then it basically just goes through all of those possible roots and subs them into the polynomial, and if that's 0, it makes a list and returns that list. But I think the hardest part of this project was definitely like figuring out like the classes and how I wanted to define polynomials using code, because I didn't really understand them at all in class, and I just kind of launched into it and then didn't really understand them in code until I got to this. Okay, so I never actually got around to doing polynomial long division. I did do something that can subtract 2 polynomials, but only sometimes correctly, and I'm not sure why. Okay, so, but I did actually like properly test the find real roots function, and that one does work, which is fun. So why did I do this? I did this, there are 2 different justifications I could give you. The first one is that I took something I didn't really understand in class, and I did a bunch of code with it. I had to really break it down and understand the logic behind it in order to write this. So if I go well in trials, that's what we're going for. If I go terribly in trials, it was expert procrastination. Anyway, but like, in all seriousness, Python has like really changed my life. Like before I did Python in year 8, and for the first 2 weeks of Python, like I thought by now I'd be a semi-famous actress, which has not panned out. No, but like seriously, I thought like maths and coding and science was like the furthest thing I could be interested from, and like now it is literally what I want to do with my life. And that's because Python has really given me the ability to like look at a problem, and instead of freaking out and panicking and being like, I can't do that, like looking at it and tackling it and actually like enjoying solving it and enjoying like getting a billion syntax errors. Yeah, so Python has really like given me tools and confidence to like pursue what I want in life, and I'm very grateful for that. Thank you. That one there.
Cool.
Okay, so I'd like to introduce Pinak. He's going to be talking about text-to-speech. Is it Viterbi? Is that how I say it? Yeah, our guess. Okay, we're going to find out. Algorithm stuff. No problem. The English language is awful. That's the subtitle. So first question, what's your favorite dessert?
Ice cream, sure.
Ice cream. And how long have you been coding?
Like 3 years.
Fantastic. Everybody, round of applause.
Cool. Hey everyone. So today I'm going to be talking to you guys about my oh, it hit second slide already. Okay. Today I'm going to be talking to you guys about my text-to-speech bot. So I call it the Viterb AI. And the reason for that is because I use HMMs and the Viterbi algorithm in order to basically take in input word or sentence and derive a kind of pronunciation out of it. But before I go into any of like the technical stuff inside of my program, I'm just going to give a brief explanation of what HMM or hidden Markov hidden Markov model and the Viterbi algorithm actually is. So the hidden Markov model is what you can see in the top left image over there. It's a bunch of states, and in between the states are a bunch of transition probabilities, and each of the states also have a bunch of emission probabilities to a bunch of observable states. You can see this in the top left image with rainy and sunny being the hidden states with transition probabilities in between them, and workshop and clean being the observable states. In between workshop and clean, you can see emission probabilities from rainy to the observables in blue, and you can see the emission probabilities from sunny to the observables in red. So what you usually use a hidden Markov model for is that basically you're given a certain observable set of states, and then you can look through your hidden Markov model to find out how likely a certain sequence of hidden states is to give out a the observable sequence that you put in. And this is where the Viterbi algorithm comes in. So what the Viterbi algorithm does is it looks through the hidden Markov model and basically tries to find the most likely set of hidden states for the observable states that you put in. So how does this apply to my bot? Well, basically my bot takes in a bunch of groups of letters, and those would be the observable states, and the hidden states would be a bunch of phonemes or groups of phonemes. And then what it does is it uses the Viterbi algorithm to look through those groups of letters and then try to find the best possible pathway of phonemes to make those groups of letters. So here's my data set. I made it myself. I wish I didn't. It took me 2 months and I hated every second of it. But so on the right, yeah, that's right. On the right side of my of the red line, you can see a bunch of words split up by dots to make them into groups of letters. And on the right side, you can hold on. On the right side, you can see a bunch of phonemes. And basically what my program does is it goes through all of these lines of words. And if you can see all of the, as many observable states there are on the left side, there are the same amount of hidden states on the right side, or I guess phonemes on the right side. And what it does is it basically sets emissions from the observable states to the phonemes and also transition states in between the phonemes for all of the words going down. But there's an issue in this. And I found that when I tried to run this with the Viterbi algorithm. And that's that it needs to be in the format on the left side. And because this is English, there are a billion ways that you can read a word. So how do I get around this problem? Well, basically, I needed to split up the word in a way that could be read. As I said, you can read it in a billion ways, so I thought to myself, I'm just going to brute force it. Yeah, so basically what I do is, oh wait, no, I skipped something. Yeah. So, yeah, I brute force it by basically using a word splitter algorithm, which I'll show you now. Down here. So for this algorithm as the demo, I'm going to be using Python. So what it does is I use regex to match the observable states that I've seen to the word. And I basically create, I guess what I'd call puzzle pieces. So the numbers on the, in the second section of the list are what can connect to the first section of the list on another list, basically. So what I start off doing is I basically set down the starting pieces. These would be the ones that start off with 0. And then I basically just run through the list multiple times over and over again, just attaching whatever pieces will stick to it. Using this method, I end up getting basically 6 maps for Python. And then what I can do with this is I can run the Viterbi algorithm on all of them and then get probabilities for each of them, and using that, I can get the most likely pronunciation. So let's look at some of the mappings. There's student, 6 maps. There's programming, 24 maps. And then here's where the problem starts. Presentational, 64 maps. Anti-disestablishmentarianism, 2,376 maps. Now, remember, I'm running the Viterbi algorithm on all of these maps, which is fine. Anti-disestablishmentarianism will only take a little under a year, so that's all right. So how do I deal with these large amount of maps? Well, what I do is I basically order them by how many states there are in it. So basically, the less dots there are in the mapping, the less states it has. So if you remember the Viterbi algorithm, because it multiplies all of the fractions in each of the states, the less states you have, the less fractions you need to multiply. So it's far more likely to be, well, more probable. So once I do this, I then have a step size which I look through. For example, the step size I'm currently using is 20. So I take the first 20 maps out of the list and then run the, find the most probable out of those first 20. And if I can find something that is probable out of those first 20, I just run with it. Otherwise, I keep on looking through the next 20 and then the next 20 and so on and so forth. So now that I actually have a pronunciation I can get from the Viterbi algorithm, I can finally run it in, I can finally use PyDub to actually attach phonemes onto the pronunciation bits. These phonemes were created by me, and yeah, it took me a good old full day. Yeah. So now let's actually look at it say something, which always is the finicky bit because it can sometimes say something wrong and then it just turns out really awkward. So let's try it with Python is awesome. So you see it map everything, and then you can see the pronunciation it's come up at the bottom of each of the maps. And then here's the sound.
Python is awesome.
And yeah, that's about it. Thank you.
Thank you, Pinak. Okay, Kaya, we have another computer swap over. Any sound? No. Okay.
Yeah, okay.
Okay. Very quickly, what's your favorite dessert?
Pavlova,
Okay. And how long have you been programming?
about like 5 or 6 years.
Fantastic. Everybody, Kaya.
Hi, so I created a Big 2 AI. So what is Big 2? So it's a card game. Has anyone played Big 2 before? Oh, okay. I love you. So it's quite similar to like poker, but the 2 of spades is the highest card, hence the name Big 2. And players take turns to play combinations that beat the last one. So when no one else can play and your play is the highest, you win the trick, which means you get to start the next one. And when a player runs out of cards, they win the round. So you can play multiple rounds. In this case, my program only plays 1. So these are the card combinations in Big 2. They're quite normal for many card games. So you can only play the same number of cards on top of another one. So you can only play a pair on top of a pair to beat it. but you can play, say, a full house on top of a straight because they're both 5-card plays. So my program has 3 quite similar AI players and 1 human player, which will be me, and they all verse each other using the game engine I created. So the interface is in the terminal, so the cards and everything are printed out there. So you can choose to either see what you would in a normal game, which is like how many cards all the other players have, and what your cards are, and what everyone just played. Or you can choose to print out like everyone else's cards and what they chose and all that, which is helpful if you're trying to show what your AIs are doing during a talk, like now. So you can also choose to do a tutorial, which is quite simple, but it just gives you some hints. So time for a demo. No, you cannot see my password. So yes, we do want to see other players' hands and information because, yeah. And let's also play in tutorial mode because why not? So the player who plays first is the player who was dealt the 3 of diamonds. So this is what they just played. So the player 1 is one of the AIs, and we are player 3. So we can then see that player 2 beat that, and then we can beat that. Does anyone want to yell out a play? No? Okay. Let's just play the 4 of hearts. So this is all quite boring because everyone's only playing single card play, so let's just pass until we get to some more interesting ones. There's a pair. Yeah, so we might not get any like 5-card plays because everyone only has like 4 cards left. So that's disappointing, but that's okay. So I'm going to start the demo now because we can't spend the entire day playing Big 2 because I only have 10 minutes. So this is my program. It's split up into several files to keep it organized. So the files sort of interact with each other. So I have like the engine and most of the functions to kind of abstract the engine a bit, and then the AIs. So I also have some classes to keep everything like neat. And so there's just the game and player classes. So the game includes the 4 players and a bunch of variables that we need. Then there's also some things for future upgrades like the scores, which I am not using yet because that's for multiple rounds. So, and same in the player, I'm not currently using this or the score because that's also for future versions, but I've like planned that. So the AI, it works by creating a list of the possible moves and then removing any that might be useful like later. Like it won't choose a single card from a triple because it might want to keep that for a triple card play or a full house, unless it only has few cards, in which case that it will play it anyway because it kind of needs to. So it can also predict when a player is about to win. So if they only have 1 card, it will quickly play a higher card to block them so they can't play their last card. Otherwise, it will play the lowest play it can to cycle through as many of its cards as possible. So what was my inspiration for this project? So I created part of the AI during the Advanced NCSS Challenge in 2018. So that was like a tournament in which everyone submitted their program and they versed each other. But after it, and so you didn't create the game engine, it was run on they all versed each other on a game engine by like Grok. So after it ended, I couldn't run it or work on it. So I then did a different course in a different language, and I created a game engine and an AI for a simplified version of Settlers of Catan. Has anyone played that? Yeah, okay. So I then came back to my Big 2 AI, and I decided I wanted to work on it, so I wanted to continue on my AI. So I applied what I did in C to Python to create the game engine so I could actually improve it. So these are my further plans for the AI, or the game in general. So I'd like to make it easier to enter a play. As you could see, you entered it in like list syntax with the square brackets and the quotes, and then something like 0s for 10 of spades, which is quite confusing and doesn't make that much sense. So that would be helpful if you could just type out king of diamonds and it would work that out. Also, this would probably be more difficult, but to create a proper website with a clearer user interface and graphics of an actual card. So that would definitely improve it a lot. So I'd also like to use machine learning to create a better AI. So that way I would actually learn instead of just the rule-based AIs I currently have, and I could test it against my other AIs and see how they compare. Also, the one you could probably tell I'm working on now is running multiple rounds. So it makes the game longer, but it's better there are several little things like scoring at the end of rounds, depending on how many cards you are, that would improve it and make it more like the actual game. So thank you. I think I did that quite quickly.
Okay. All right. Second last for the day. Sorry. That's a good point. It helps if you plug things in. Yes. Okay, second last for the day. This is Angus, and he's going to be talking about extending student programmers with open source. Angus, what's your favourite dessert?
All of them.
All of them. And how long have you been coding?
About 6.5 years.
6.5. That's longer than I've been coding. Okay. All right. Round of applause.
Thank you. So for the past 3 years, I've been lucky enough to be part of a community organisation called Charcoal, which works on several open source projects that operate together to keep Stack Overflow and the rest of the Stack Exchange sites free of spam and rude or abusive posts. Being part of this open source organisation has taught me a lot about programming in general, taught me many professional skills, and I've found it an invaluable part of my career development over the past few years. So I've come here today to give you a bit of an overview of what I've been working on, why I found it a really valuable experience, and why I think other students should get involved with open source as well. As an organisation, we developed two main systems. Smoke Detector, which is a Python headless chatbot written in Python 3, and also Metasmoke, which is a web dashboard written in Ruby on Rails. Smoke Detector is responsible for finding and classifying spam, as well as accepting user commands from chat. And Metasmoke is responsible for archiving all of the posts that we've caught in the past, which is useful for future data analysis. It also has responsibilities in relation to user management, system orchestration, and automatic flagging. So how does it work? It all starts with the humble real-time questions page on the Stack Exchange homepage, which shows every single new question, answer, or edit across the entire Stack Exchange network. This page is powered by a WebSocket, which Smoke Detector connects to in order to access a feed of all posts which need to be scanned. Next, it fetches the full contents of every post from the Stack Exchange API and runs them through our extensive suite of spam checks. So how do we actually determine whether a post is spam? A variety of methods are used, but the main answer is regular expressions, also known as regex. If you're not really familiar with the term, regexes are basically a really concise and powerful method of pattern matching text. More specifically, however, smoke detector checks for typical spam patterns, such as a one-character link in body, or a domain name similar to a username or something like that. Blacklists and watch lists of over 17,000 keywords, domains, usernames, that sort of thing, that have been used in spam in the past. Also, blacklists of user accounts who have posted spam in the past. We also perform lookups of name servers and whois information for domain names. And finally, we connect to external APIs, such as Google's Perspective machine learning service, which helps us detect toxicity in online discussions. So for the folks who have been over in the data science track today, you're probably wondering, why don't you use machine learning? Well, I'm glad you asked, or didn't really. There are two main reasons. First of all, there's a huge spectrum in the types of posts that we look at, and there's a lot of intricacies to the definition of what's spam and not spam on Stack Exchange, and this makes it a very hard problem to solve using machine learning. Second of all, it's just not our area of expertise. So subtle plug, if you know what you're doing, you should totally help us out. We'd love to have you on board. See me afterwards. So now back to the main topic at hand. So I've identified which posts we think are spam and which ones are not. So what happens next? Well, two things. First, Smoke Detector posts a report to various chat rooms where humans will look at the post and determine whether or not they think it's actually spam. They can also flag the post manually if required. We also have an auto-flagging system where once the report is sent to Metasmoke, it'll use our historical accuracy of each of the individual detection reasons to determine how likely we think the post is to be spam. If we're more than 99.75% sure that the post is spam, we'll cast up to 2/3 of the required flags to delete a post. Together, these manual and automatic measures have been very effective in deleting spam. On average, posts are deleted less than 80 seconds after being posted for obvious spam. Overall, our project's been very successful in detecting and deleting spam in a fast and efficient manner. Since we started collecting data about 4 years ago, we've caught and deleted over 135,000 spam posts, cast over 165,000 automatic flags, in addition to the human ones, and also collected over 470,000 user feedbacks on whether posts actually are spam. It's taken spam from a problem that used to be a big problem on Stack Exchange back in the day to something which now is barely noticeable to the casual observer. So now it's time for the why. Why do I believe it's worthwhile spending time on open source? And why do I believe that other students should do it too? The obvious answer is it improves your technical skills. There are many advanced language features in Python, such as first-class functions, and threading and multiprocessing, the more advanced data structures, such as those in the collections module, decorators, that sort of thing, that are hard to understand when you see them at first glance, but it's not until you see them in an actual real-world project that you go, aha, that makes total sense now. Like, if I were to start a project from scratch, now I'd know how I'd actually use it. Working in open source also gets you to learn many of the other technical skills that you need day to day in an actual job, but are often overlooked in many formal courses, such as version control with Git and GitHub, continuous integration and continuous delivery, unit testing, code linting, dependency management with virtual environments, and also managing and securing servers on cloud platforms like Amazon EC2, and effectively using a bash terminal on Linux. Finally, one of the major technical advantages of working on an open source project is the sheer scale that you get to work on. When you're developing a piece of software, there are some bugs and deficiencies that only really manifest themselves when you're working at a big scale, whether they be race conditions when you're accessing external APIs too often or too fast, or race conditions when you're working with multi-threaded code. This sort of scale requires you to think and code very differently. And it's not until you're working on a real-world project that you actually learn some of these skills about effective program design and proper debugging techniques. And open source is a great way to learn that. Now, of course, it's not only the technical skills that you learn by working on an open source project, but also the many more important soft skills. I'm constantly working as part of a team, collaborating with other people, performing code reviews, helping to maintain both my own and other people's code. Ever since I became part of the leadership team of the project about 2 years ago, I've had to contribute to making high-impact decisions, mentoring new users, that sort of thing, and just taking on other leadership responsibilities. Effective communication is also something that you become very good at very quickly. Because none of us know each other in real life, obviously, we all have to communicate via writing over the internet, whether that be a GitHub pull request or code documentation or, just writing a post on a website. You have to learn very quickly how to communicate clearly, concisely, and accurately. You also learn how to give and accept constructive criticism, which is something I deem to be a highly underrated skill. It's this wide range of skills that you learn by working on open source, both technical and soft skills, that makes it such a highly marketable activity. It's something that's let me have experience in working on nearly every aspect of being a professional software developer, except for the bit where you get paid. But that'll come. It's something that looks great on a resume. Recruiters love to see it, and that's something that's been really helpful now that I'm reaching the stage in my life where I'm starting to look for internships and other job opportunities as I move into university. So on a final note, working on open source as a student has been an amazing opportunity, and I've really enjoyed every moment of it. I've met so many amazing people over the past couple of years from around the world who know so much more than me, and it's been an absolute privilege to learn so much from them. Although my personal contribution to the project may be small, it's amazing to see what we can do when we work together, and that's been really rewarding. It's an experience that I think other students could also really benefit from, and so that's why I encourage you guys as educators to recommend your students to get involved with this too. Thank you.
Thank you, Angus. Okay. And this is Eve. Eve's going to be talking to us about building a fake news detector using natural language processing in Python. Eve, what's your favourite dessert?
I have to say rhubarb crumble.
Actually, no, yes, we're talking later. And how long have you been coding?
About 2 years. Hey everyone, my name's Eve and I'm a Year 12 student. I go to a school on the Central Coast called Gosford High, and I'm in Year 12. I actually had a trials exam this morning because I like to live dangerously and I came here. And this program is part of my major work for my software course. So when I was originally thinking, what do I want to do for my major project, there were two main things that I wanted to include. The first was I wanted to explore an area that I'd never seen before because I like to live dangerously. And the second was to create a project at the end of it that might not be completely usable, completely viable, but that I could show to people and it would be some thing that I could work on later. So what I did was make a website where you input news articles that you might be curious about how real or fake they are, and it'll give you an output that'll give you some indication of its reliability. Now, I'm sure you're all global citizens, you all read the news, and I'm sure you've all come across articles like these. My favorite is the one on the left by Natural News, which I don't know if you've heard of, but it's like a gem if you're bored or want to look for some crazy headlines. Because as you can see, there's a nice mix of vaccine denial and really obvious political slanting. And after seeing all of these articles, I thought, I got to do something about this. This is crazy. Yep. Also, we have some other news sites, Breitbart and Rebel Media. These are some less obviously inflammatory news sources, but there's some pretty obvious things that make them unreliable. For example, Rebel Media has a store tab as the second tab on the website, which isn't a great sign. So when you're looking into creating a problem like this, as I said, this was the first time I'd ever done something like this before, so I had to sort of consider how on earth do I teach a computer what's real and what's fake news, and what does that even mean? And the way I did this was through, I would say, like a sort of general machine learning structure. So the first thing I needed to do was get a lot of data to teach a computer what the hell is an article, what's a real article, what's a fake one, what do they even look like. So I went through 8 different news sites. The one on the top 4 are what I dubbed as fake news sites. They're really extremist. I would say they're like the worst, most hyperbolic example of a fake news source that you could get. And the 4 on the bottom, hopefully more of you will recognize these ones. These are sort of popular, big mainstream news companies that I thought would be a good baseline for something that's generally considered quite accurate. Hopefully, all the ABC, SBS, those sort of things have respectable, well-trained writers that go through some level of base control, unlike these other articles on the top. So I made a web scraper, which is just a little piece of code that went to all these articles. It went through like a little spider, and it took hundreds, about 2,000 URLs from each news site, and then it went to each of those URLs, and it just copied all the text from it and put it into this big Excel document. So overall, we got about 16,000 news sources for training data. There's really no like limiting point for training data as far as I've been told. Just get as much as you can. But for the scope of this website, I thought 16,000 was okay. And I also had to label the data. That's the other point that's important about this data set, is that I had to teach the computer, this is what a not fake website is, and this is what a fake website is. So what happens after that? So you have all these news articles, and you've got them there on your computer, but your computer still doesn't speak English. It doesn't speak any language. It's just a computer. So one of the ways we begin to get our data into a medium that a computer can understand is called pre-processing. So the first step generally I did in pre-processing was standardizing all the case. So I went through all the articles. I made it all lowercase. And the reason I did that is because when you're reading a piece of text, say the first word in the sentence is the, and if the starts with an uppercase, because it's at the start of a sentence, our computer will read that and think it's a different word than the with the lowercase. So that's not intuitive. We don't want the computer to think that they're different words. We standardize all the case. We also get rid of all the words like the, because they don't generally connotate meaning. And what we're doing from this is we're trying to gather meaning from our articles. So words like in, and, as, they don't really mean anything in the traditional sense. So then what do we do? We've got all this text. Again, still the computer doesn't speak English. So we have to turn it into a number. This process is called text vectorization. I don't know if that's a real word, but it's turning text into a number, essentially. And this is the big statistical scary algorithm that's been on the screen for a little while. Basically, this algorithm, what it does is you read through, it reads through the text, gets a word, it says how many times does this word appear in an article? Say it appears a lot. You'd think, oh, that's a pretty important word to this article. It's appearing all the time. But if that word appears a lot in all articles ever, it doesn't really mean anything. It doesn't translate to the meaning of an article. So what we want is a word that appears a lot in fake articles, but not a lot in true articles, because then it's generally informative to saying, oh, this is probably a fake article if it's got this word happening all the time. So that's essentially what this statistical thing means. A big number is a really important word. Like a smaller number is a lesser important word. So what word vectors are generally really cool at doing is relational aspects. Now, I'd say the main goal of natural language processing is to try to get computers to understand what words mean, the same way that we understand what words mean, which is like intuitively, easily, and I'd say word vectors are a big step in doing that, because what they're really good at doing is saying like, man is to woman as uncle is to aunt. So what you can do with these numbers, and this is one of the first things I did when I started learning about natural language processing, is you can literally get the number for king minus the number for man plus the number for female, and you'll get the number for queen, which is insane, and I love it, and it's kind of magic, because they're just numbers. And obviously you use the statistical techniques to get the numbers, but when you actually think about that, it's like, it blows my mind. And yeah, obviously there's a lot of complex stats as to why that works, but I think it's really interesting that it does work, and yeah, I just wanted to highlight that. So this is how my website looks now. It's a bit small, but we'll get to it later. What you do is you get an article of your choice. You put in the text of that article, just all the content. You put in the title and the URL. Now, I wanted to have 3 inputs because I'm telling people what truth is, which is already really like vague and ethically dubious. So I wanted to have as many filters as I could to kind of give you a good indication of whether an article is real or false. So that process I went through just there, I did that for text and titles. I didn't gather my own data for the titles. I used just a big data set I found on GitHub, which I've sourced on the website if you're interested. But for URLs, I didn't think natural language processing was really appropriate. Like maybe if the URL looked really shifty, you'd be able to machine learn that. But I think it was better to just have a flat list of known shifty domains. So that's all that does. It just checks against a flat list. If it can't find anything, you don't get a result. But just in case there's a really convincing title and a really convincing text and the machine learning is like, yes, this is good, but then you realize it's from The Onion and it's satirical and it's not good. And then you get a results page. Essentially, you get a binary sort of judgment. So it gives you, it tells you the article is not fake, or it tells you it's true, and it says how competent it is in that judgment, because it's more informative to do that. And it also tells you if you can find any information on the domain. If you can't find any information on the domain, that's like a good thing, because it means it's not on this shifty domain list I have. Yep, and this is the URL, so feel free to take pictures if you're interested. It's online, you can access it. If you can't access it, come and find me and shake me down. But yeah, that's pretty much it. Thank you for listening.
Thank you, Eve. Okay, weren't they fantastic? Big round of applause for all of them. And that's the end of the education track for today and the student showcase. So the students are going to remain for a little bit longer. They definitely are, because their photos are required. And apparently Google is trying to solve problems for me. And so they're there for asking questions. Other than that, there's a little bit of an early mark for you. I hope you enjoyed today, and we'll see most of you tomorrow.